The rules of the challenge are pretty simple. The container should run a web server, accessible on a port of your choosing, and serve the contents of some file on the file system.
Hey guys,
i.e.,
it turns out that Sid from the DevOps Directive has just issued a challenge directly to us. Now, if you don't know who Sid is or the DevOps Directive, I highly recommend you check out his YouTube channel. It's linked down below. Now, in this video, he goes into a lot of details on what and how he made a really small container. And if you want to know how big the container is, the container image at the very end was something like 6.27 kilobytes of data. Now, I highly recommend you watch his video explaining the steps that he went through, because those are fantastic steps and steps we're not going to repeat. He already did them. Now, our challenge today is to make a smaller image. And I was going to break down to you the steps I took to beat his image size, and in the end, how I got a smaller image. Now, I'm gonna have to tell you a little bit of a spoiler of his video. To get such a small image, what he had to end up doing was using a web server that was written in assembly that was designed to be the smallest web server possible, and then using a Docker Scratch image. So this web server was statically linked to everything that it needed, which was very little, and put into this Scratch image, which is just an empty container. Now, why does this matter? Let's get into that. Let's go ahead, jump into the computer and understand what a Scratch image is, why it allowed him to make a smaller container, and what tricks we had to pull off to beat Sid's container. Jumping into the command line, let's go ahead and look at the files that I have put together. Now, I'm going to push this all to Git so you guys can also see these files if you so want to. If you see here, I have done a couple of things. So my first thought was to just try to use Rust. Rust makes pretty small images, but I don't think it's going to get nearly that close. So I have made a very small Rust server that serves a file. And we can check out that Rust file. So let's do that. And here's the tiny HTTP. It's designed to be tiny, kind of what we want. All right, so on that, we have also a Docker file. All right, and so I just do kind of, I'm gonna say best practice. This isn't a really secure one, but what I did here was to build Rust, and I built Rust, as you can see here on this line, with statically compiling everything the image needs. This way, when it goes to run, that one binary has everything, which allows me to build my image from scratch. So my the second stage of this multi-stage build here actually takes from scratch, and it just copies in the smallest image binary because it's all statically compiled together. This is going to pretty much make the smallest Rust image I can get. So what Scratch does is it's an empty container. A lot of the times you start from Ubuntu or whatnot, and these containers have the user space of Ubuntu, which means it has apt and it has these other tools in it that you don't necessarily need for a production container. Scratch is kind of what's the base for you building containers off of. It's an empty container with nothing in it. It is 0 bytes on your file system. All right, so this should be the smallest Rust we can get. Let's go ahead and build it. So we're going to run docker build. We're going to give it a tag. So as you can see here, we're doing the first stage of the build, and then it's going to go on to the second stage as soon as it's done. All right, so yeah, there's a warning that is emitted, and you know what? It's not a big deal because this isn't real code. Let's go ahead and run Docker images. You can see these untagged ones. If you've ever gotten these and wondered what they are, they're intermediate builds. That's why they don't have a name, or you built an image and didn't tag it. So it's either on you or it's an intermediate build. Not a problem. Well, cool. We can see that these intermediate Rust builds here were relatively large because they had everything for compiling and managing Rust. They probably even had package managers. But what we can tell here is, check this out. our Rust code is only 4.5 megabytes in size, and we could work on maybe removing some stuff from the Rust server or things like this. But honestly, this isn't even close to the 6 kilobytes, so I kind of abandoned it at this point. This works, and I have a small web server, but it's not even close enough to give me the starting point to beat SID. So what else can we do? We could take the assembly project and we could actually just remove parts from it. And this would give us a smaller binary, but only a little bit. And I would have to dig around in assembly. And that seemed like way more work to beat SID than I wanted to do. I really wanted to be kind of lazy and beat SID. So I came up with another plan. Let's go ahead and do that right now. The first step I'm going to do is just this one right here. We're going to go into the Docker file, and we're going to just remove this line. For the sakes of the repository, I'm going to leave it commented, but we're going to remove this. So our final image here is now going to be a from scratch. Let's go ahead and build this. Nothing. I didn't include anything in it. This still has the multi-stage, and that's only because this is going into the repository. I could have made multiple Docker files, but I thought that this was an easier way just to have it all in the same Docker file for you guys. As you can see here, we built this smallest nothing latest very quickly because there's pretty much nothing that happened. Let's check out our Docker images. This is pretty much what I expected. So as you can see here, there are 0 bytes in the Scratch container. This is basically just Scratch. There's pretty much nothing done to it other than Scratch. And this is what we wanted, right? We wanted the smallest image. Now, technically, SID said that we needed to serve a file on a web server with this. So what I'm doing with this command is cheating, but SID never specified what else to do. And so this is how I've gotten a 0 byte container. What I've done is actually just mounted my home file system into the container at runtime. This means when this goes to execute the default command, the file will exist there. As you can see, I'm mounting it into target. So I'm going to mount the smallest image executable into /target. And I'm going to run the smallest nothing image. The server actually prints hello world when it goes ahead and run. And there it is. We can now also expose the ports and see it in the web browser. And let's go ahead and do that. All right, so if we're wanting to expose this to our local machine, it's really quite simple. And we're just going to use the -p to expose a port. And what Docker is going to do is it's going to set up a proxy between my machine and the container runtime and proxy all the requests to that container. Now that container is going to be running our image, which is 0 bytes, and it's going to return hello world from a file. That is all that you have to do to cheat at a competition that was given to you. Although the official rules never stated anything about whether the binary had to actually be compiled into your image's file system. Other than that, he released a really good video. I wanted to support his video, so go check out his video. Let him know that you came over from my channel, and go see the work that he did because it is some phenomenal work. Other than that, I hope that you guys have a fantastic day. Saw how to cheat the file system of a Docker image, as well as the fact that you can actually run something from outside your Docker container's image in your Docker container. All you have to do is mount the file system in there to do that. I don't actually think that this is recommended or useful, or you should actually do this in any sort of production manner. This is not what I'm saying, and please never tell somebody that I said to do that. If you think of an interesting way to use this, do leave a comment down below about how you might use this and why it might actually be useful. I have a hard time finding a reason why this might be useful, but I thought that this was fun and I would share it with you guys. Now, if you don't know, I'm making my videos a little bit more fun like this, where we do some little bit more fun, but maybe not as technical things. And I'm starting to release classes. So my first class on containers has just been released. And if you want to go and check that out, I will be releasing a new short class segment every single week. So that allows me to have a little bit more fun and dig into some of the nerdy things without needing to explain everything. This is going to let me dig into things like Kubeflow without having to feel like I have to explain absolutely every single piece, because really I got bogged down with Kubeflow because it's a very complicated thing, and to explain it in enough detail was very cumbersome and very difficult. So now I'm going to get to explain it at a little bit of a higher level and have a little more fun with it and bring you guys more content on things like Kubeflow, because it's easier for me to bring you that type of content. If you did not like this video, I'm going to need you to go ahead and like and subscribe to Sid's video on DevOps Directive. And if you really didn't like this video, I need you to hit that subscribe button, stick around, and see if these videos get any better for science.